Hello, welcome to another video. I'm going to again take a look at why it's interesting to use the polar form and take this into an important theorem which allows me to make powers of complex numbers quickly. So I'm going to go again through a lot of stuff that you already know and end up with a high note on something new that I hope becomes relatively logical and familiar with you. So again, what was the whole point of using complex numbers in the polar form? Here I have a little friend to remind me because it's easier to multiply and divide. So for example, again, like you might think, well, I kind of like the Cartesian form a bit more. I think that this is not that hard to deal with. Well, when things start to get a bit more messy and you end up with something like this, you will be happy to have the polar form to operate with because it's going to be easier. So again, to move things into polar form very, very quickly, if I have these complex numbers, to calculate the modulus, I just use Pythagoras. To calculate the argument, I just use the inverse of the tangent, and so forth. And normally to write it, rather than write it like this, modulus is this, argument is this, what I will actually write them is this way. And it's just a shorthand way to say cosine theta. So cosine of 26.57 plus I sine of 26.57. When I operate in the polar form, this is how you do it. Given this complex number and given this complex number, what you're going to do to multiply them is you're going to multiply the modulus. And the arguments, you're going to add them. And that's going to give you the answer. To divide them, you're going to do it, divide the modulus and subtract the arguments. So what's the consequence? Let's start with an example. I have this complex numbers and I'm going to do multiplication and division. Multiplication, I multiply the modulus, 4 times 2 is 8. I add the arguments, pi fourths plus 3 pi halves gives me 7 pi fourths. And division, I get the following answer. Okay, you get the idea. What happens if I'm actually going to do z times z times z? Z to the power of 3, right? Z times z times z, that's going to be 4 times 4 times 4 times CIS and pi fourths plus pi fourths plus pi fourths. So ultimately, if you think about it, what you're doing here is 4 to the power of 3 times CIS 3 pi fourths. Great. So you see the pattern here? You see what's going on? Look at it again. And the complex number to the power of 3 is just the modulus to the power of 3 times the argument. So that's going to be happening for any complex number. So the modulus to the power of n, and just take the argument and multiply it times n. And that is De Moivre's theorem, which is a very useful theorem when operating with complex numbers. So if you ever need to calculate something like this, trust me, rather than start crazy operations, take it into polar form and then use De Moivre's theorem, and your life is going to be much easier. Thank you very much for watching.